Okay, we're going to graph a line here. When you graph a line, all you need is really two things. You need to know where the line is and how steep it is. And that's pretty much it. So to do that, if we have it where y is by itself, like this one, we can find out where it is by looking at the constant, this -4 right here. So -4 is going to be our y-intercept, where it crosses the y-axis. Remember, the y-axis is the vertical axis. So we know it crosses here. And the reason that point is important, it just helps us locate the line. There's lots of places we can put it, but the most convenient point is the y-intercept. So now I know it has to go through that point. I've located my line. I've just kind of nailed it down. And the other thing I need to know is how steep is it? Well, you get that from the coefficient of x. This is the slope. And the slope is rise over run, as you've heard many times. So the rise part is the vertical change. So from this point here, not the origin, but from the point where you nailed it down, you go up 1 and over 2. Rise 1, run 2. And you can continue to do that if you'd like. Up 1, over 2. All you need is 2 points. That's sufficient. But some people like to do several, so you can better draw it in there. Or just use a ruler. But here's your line. Right through here. All right. And what this line does, it shows you all the points that are solutions to the equation. For example, this point here, which is on the line, is the point -4, -6. Remember, it's an ordered pair. We write it in a particular order for a reason. -4 must be the x, -6 must be the y. But if I go back to the equation, I plug in -6 for y and -4 for x, it should be true. That's what a graph is. It just shows you where all the solutions are. -1/2 times -4 is +2. Sorry, that's +1/2. 1/2 times -4 is -2. -2 minus 4 is -6. So this is in fact true. And you could do that for any point on the line, including the ones that are in between them, even though those would be a little harder to check. Anything that's shaded would be a solution here. Show you one that's an inequality. So we have y is greater than 2x plus 1. Since y is by itself, we can graph it the same way. What we're going to graph is where the two sides are equal. I'm going to put a point where 1 is. Remember, that's my y-intercept. It's the most convenient place I can show where the line is. My slope here is 2, which is equivalent to 2 over 1. So I'm going to rise 2, run 1. And again, you can do that multiple times if you want. You don't. All you need is 2 points, but you can do it multiple times. Now, if I connect those with a line, I'm showing you where the two sides are equal. But I want to know where y is bigger. In this particular case, it says y is greater than and not equal to. What I'm going to do is dash this line. The reason you dash things in math is to show it's a significant part. It's like a border. But the border itself is not a solution. If I made it solid, then I'm saying it's okay to be on the border. But I'm not okay to be on the border, because if I'm on the border, these two sides are equal, but there is no option for that. It says y is greater than. All right, now, remember, y is, when with inequality, there are many solutions, not just on the line. There would be many. So what I need to do is figure out which side does this work for. And there's a couple ways you can do that. One way is sort of get this intuitive sense of what's greater than and what's less than. This is why it's greater than. So greater than would be on the upper side, and this would be the lower side. Now, many people have a hard time distinguishing which is which. So another thing you can do is just pick a point that's not on the line, because if it's on the line, it's going to make the sides equal. Just pick a point like 0, 5, which is clearly not on the line. and stick it in there and see if it works or not. So remember, 0 is x, 5 is y. So I'm going to do 5. Is 5 greater than 2 times 0 plus 1? Yes, 5 is bigger than 0 plus 1 or 1. Okay, so since it works, it should therefore be shaded. That's what a graph does. Anything that's shaded means it's true. That's why we shade it. A graph is just a picture of all our solutions. So I'm going to shade, literally just shade all of this. Okay, any point within the shading makes the inequality true. That's what it's for. But if you're on the border, it's no good. That's why we dashed it. Anything that's on the other side of the line is no good because it would be less than instead of greater than. Do one more. So we have a 6x plus 2y is less than or equal to 6. Now, one thing you could do is get y by itself so you can find the slope and the y-intercept. But what's easier here, if x and y are on the same side, is just to find the two intercepts. Remember, an intercept is when one of the coordinates is 0. So the x-intercept is when the y-coordinate is 0. What I can do is just cover it up or erase it, the 2y, and ask myself, what value of x would make 6x be 6? Just disregard the y, because if you're on the x-intercept, the y is 0 anyway. Well, 6 divided by 6 is 1. So I'm going to put a dot on the x-intercept at 1 because I put 0 in for y. And for the y-intercept, you do the opposite. Just cover up the x. If you're on the y-intercept, x has to be 0. So 2y equals 6. And a little mental math, obviously y would be 3 there. So I put a 3 on the y-axis. And remember, all you need are 2 points. So I can connect this. And this time, I'm going to do a solid line. Okay, the reason I'm going to do a solid line is because the border is good this time. Okay, because if you fall on the line, it's going to be equal on both sides, but you have that option here. So in short, if the inequality is underlined, you make it solid. If it's not underlined, you make it dashed, because if it's not underlined, the border is no good. You have to dash it to show that. This is a less than, so the shading is going to be on this side, but if you're not sure, just pick a point. The origin is usually the best point if it's not on the line. If it's on the line, you have to pick a different point. So I'm going to pick the origin here. And if I put 0, 0 in there, it's just going to be 0 plus 0. 0 plus 0 is less than 6. So that side should be shaded. So I'm going to shade everything over there. Okay, so if you're in the shaded area, you're good. If you're on the line, you're good because it's solid. But if you're on the other side, it's not shaded, so it's no good.